Hello and welcome to my TED Talk. Today we're covering the 9th edition of the physics textbook. We're going to be doing chapter 27, section 2, problem 16, which is not the same chapter as it is in the 11th edition book, but I don't have that edition. So the problem that we're going to solve is that a conductor of uniform radius of 1.2 centimeters carries a current of 3 amps produced by an electric field of 120 volts per meter. And we're asked to find the resistivity of this material. So the first thing I notice is that the radius is in a unit that I don't like. So I'm going to change that to meters real quick. So we have 0.012 meters, and that's a uniform radius. So we know that this conductor is a circle or a disc with uniform radius all the way out. And it has an electric field of 120 volts per meter. And we're asked to find the resistivity of this material. We know that resistivity is the electric field divided by the current density vector. Now we do have the electric field, but we do not have the current density vector. So we're going to have to find that too. And we know that the current equals the integral, the current density vector, times dA. Now in this scenario, the current density is constant throughout the material. And so since it's constant, we can pull that out of the integral. So we have I equals the current density vector times the integral of dA. And now the integral of dA is just going to be a. And since this is a disk, we know that that equals pi r squared. And so we're going to take that integral and then just divide that over to the current. So we have current divided by pi r squared equals our current density vector. Now plugging in numbers, we have 3 amps divided by pi 0.02012 meters equals our current density vector. I already solved that. That's going to be 663 amps per meter squared. All right, so now that we have our current density vector, we're going to take that, we're going to plug it into our original equation. P is going to equal 120 volts per meter divided by 663 amps per meter squared. Now, once we divide these, which I also already calculated, we get 1.81 times 10 to the negative 2 ohms times meters. And so we know that that's the correct answer because if you check your units, then these cancel out and these cancel to ohms, and we get ohms times meters. So our final answer is that the resistivity of this material is 1.81 times 10 to the second. Thank you for coming to my TED Talk.